And we talked previously last week about reflections, and we talked about translation. So today we're going to talk about rotations. And a rotation is a transformation that turns every point of a pre-image through a specified angle and direction about a fixed point called the center. And it rotates it through an angle of rotation. And so I've got a picture of kind of what one looks like. It's a little bit distorted, so kind of bear with me on that. But we're going to take and we're going to rotate this pre-image to this image. And we're going to rotate about this point of rotation, okay? And we're going to go 100 degrees counterclockwise rotation about that point P, okay? Now, in the past, or one time, maybe twice, I did this. We actually did it by hand, and it's kind of hard to do. It's horribly hard, but it is a little bit hard to do. So I'm just going to kind of show you what's happening. And we're just going to talk about how to move one point, but I have to do this with each of the points. But you have your pre-image, okay? This one's actually, the green one's not actually here yet. But you have your pre-image, and you draw a line segment from your point of rotation to one of the points, okay? Then with your compass, you measure 100 degrees in the counterclockwise direction. Then you draw another line the same length as this one. Now this is where it's a little bit distorted. But from P to PL and then P to L prime, those should be the same length. They don't really actually look at like it, but kind of pretend they do. And so then that's where my new point is. And if I do that with each one of the points, I rotate them 100 degrees in the counterclockwise direction, and I keep that distance the same. Then this is the image, the green image, is congruent to the red pre-image. Okay, if I did that for each one of the points. So we're not going to do that. We're going to kind of take the shortcut way out, and I'm just going to give you the coordinates, okay, and it'll do it for us. Now these coordinates work only when you're rotating about the origin. If you rotate about a different point, it gets a little bit different. But the first one we want to talk about is a 90 degrees counterclockwise rotation. Always assume counterclockwise unless specified otherwise. So our first one is a 90 degrees counterclockwise rotation. And so what you do is you take your point, you change the sign of the Y, and they switch places, okay? So if you look here, you got a 90 degrees counterclockwise rotation. I'm looking at the point 4, 5. Okay, if I rotate it counterclockwise 90 degrees, then I change the sign of the Y, and they switch places. So it ends up being negative 5, 4. Now, a 90 degrees counterclockwise rotation is the same as a 270 clockwise. So the rules for those would be the same. And the way that I remember this is no matter where the point is actually on the graph, just help me to remember the rule. I always think of it in the first quadrant. And if it's in the first quadrant and I'm going to rotate 90 degrees, I have to go over the y-axis. And so that's the coordinate that changes signs, and then they switch places. Okay, so that's how I remember it. 180 counterclockwise rotation. Now 180 counterclockwise and 180 clockwise is the same thing, okay? And the rule for it is you just change the signs of the coordinates. So if this right here is 4, 5, when I rotate 180 degrees, it becomes negative 4, negative 5. And the way that I remember this one is that if I'm in the first quadrant, they're both positive, right? If I go 180 degrees, they both become negative because they're both negative in the third quadrant. Even if I was in the second quadrant going to the fourth, here I've got a negative positive. When it comes over here, it becomes a positive negative. So they still switch, they switch signs no matter what. So the rule for the 180 is you just switch the sign of the X and the Y. Then we want to talk about a 270 counterclockwise rotation, which is going to be the same as a 90 degrees clockwise. Okay, and the rule for it is you change the x-coordinate and they switch places. Okay, you change the x-coordinate and you switch places. So if my point is at 4, 5, then I'm going to change the 4 to negative and it becomes 5, negative 4. So again, I kind of used the rule that I used up above. No matter what the point is, I say, okay, well, if I'm in the first quadrant and I want to go 90 degrees clockwise, which is the same as 270 counterclockwise, I have to cross over the x-axis, and so that's the one that changes signs, and they switch places. If I want to go 90 degrees counterclockwise, I have to go over the y, and it's the one that changes, and they switch places. Okay, so let's work a few problems. We want to rotate trapezoid FGHI 90 degrees counterclockwise about the origin. Okay, what's the rule? What's the rule for 90 degrees counterclockwise? Okay, the y changes signs and they switch places. Okay, so this becomes negative 7, 7, negative 2, 9, negative 2, 3, and negative 7, 5. So you change the y and they switch places. So if I graph that, negative 7, positive 7, there is my f prime. My g prime is at negative 2, 9. My h prime is at negative 2, 3. And my I prime is negative 7, positive 5. Okay, and so then you connect your points. Okay, 180 degrees counterclockwise rotation. What's the rule for that? Just change the signs, right? That's all you got to do. All right, so change the signs. So my W prime would become a positive 1, a negative 8. X prime becomes 0, negative 4. Y prime becomes positive 2, negative 1. And Z prime becomes positive 4, negative 3. All right, so 1, negative 8. There is W prime. 0, negative 4. There's X prime. 2, negative 1, Y prime, and Z prime is 4, negative 3. So we connect, and that gives us 180 degree rotation, clockwise or counterclockwise. And something that you might want to do, like if you're trying to identify what's happening, always look at what's happening from the, the W to the W prime. Okay, kind of look at it like that. Sometimes that's helpful. All right. We want to rotate trapezoid ABCD 270 degrees counterclockwise about the origin. What's 270 degrees counterclockwise is the same as 90 clockwise. And what's the rule for that? Change the x and they switch places. So y negative x. Okay, so this becomes 0, negative 9, A prime. B prime becomes negative 7, negative 6. C prime becomes negative 7, negative 3, and then the origin, nothing happens there. Okay, so we have 0, negative 9 for my A prime. My B prime is at negative 7, negative 6. This thing's shaking. C prime is at negative 7, negative 3. And then your D prime is the same as your D because it's the origin. So we connect our points and we get a 270 degrees counterclockwise rotation, which is the same as a 90 degrees clockwise. All right, now the next thing we want to talk about is rotational symmetry. And rotational symmetry is when you can take and rotate a shape and it's indistinguishable from where it began. Okay? You can go between 0 and 360 degrees and you can't tell that it's rotated. Here are some examples of things that have rotational symmetry. if you look at this, this right here is your point of symmetry. That's the point of rotation that you rotate about. I could take and rotate from here to here, and you would not be able to tell. Okay, you would not be able to tell. There's lots of examples of rotational symmetry in nature. Now you kind of have to give it a little bit because nature sometimes gets a little mixed up with what it's got. Like these two petals are a little bit closer together than any of the other ones, but still in general it's got the rotational symmetry. Here we've got a pinwheel that has some rotational symmetry. Now, the number of times that it can be rotated so that it meets back up to where it began is called order, okay? And so you would count, like I would start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could do 9 different rotations to end back up where you began, okay? So this one has an order of 9. This one, you can start here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21. This one has an order of 21. So it could rotate 21 times until it got back to where it began. What would the pinwheel be? It would be 4. Now, you could get a little sticky about it, and if you were wanting the stars and stripes to match up, it would have an order of 2, right? But we're just working with the pinwheel, so we'll say that it has an order of 4. Okay, now, the angle at which it rotates, is called the magnitude of symmetry, okay? And to find that, you take 360, because there's 360 degrees in a circle, and you divide it by the order. So if we come over here to this Ferris wheel, I would need to first of all know what the order was. So we can start there with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? It has an order of 16. So then to find the magnitude, I'm going to take 360 and I'm going to divide it by the order, which is 16, and I end up with 22.5. Okay? And so, this angle right here between these is what is 22.5. Now, if it asks you questions on your homework, make sure you go counterclockwise, okay, unless it specifies otherwise. Okay, so a couple of questions in regard to that. State whether the figure has rotational symmetry. Write yes or no. If so, copy the figure, locate the point of symmetry, and state the order and magnitude of symmetry. Okay, so does this one have rotational symmetry? Yes. Okay. The point of symmetry would be right in the center. Okay. And what would the order be? 6. And what would you do to find the magnitude? 360 divided by 6, and so it would have a magnitude of 60 degrees. Okay. What about the right triangle? Does it have rotational symmetry? No, it does not. What about the X? No, you don't think so? I'm going to show you some magic. Okay. All right. If I took and I rotated about the center, and I continue rotating, if I go 180 degrees, what happens? It matches back on, doesn't it? Okay. And so then I go back up here to where I started. Okay, so does this one have rotational symmetry? Yes, it does. The point of symmetry would be here in the center. Okay, what is the order? 2. And the magnitude would be what? 180 degrees. All right, any questions? No questions? All right, your assignment is on the board.